Hi, I'm Sarah Prescott, Executive Director of BioQuest and one of the co-facilitators for this Adapt and Implement Faculty Mentoring Network, or FMN. This FMN brought together an amazing group of faculty who were interested in adapting and implementing open educational resources as part of the American Chemical Society Green Chemistry Institute's Teaching Module Development Project. We're excited to hear from them about the great work they accomplished and the lessons they've taken away from this experience.
Hello, hi, my name is Flavia Sacconi. I'm a professor at the Pontificia Universidad Católica de Chile in South America, working at the Faculty of Chemistry and Pharmacy and the Institute for Biological and Medical Engineering, and a member of the ACS, currently participating in the ACS Faculty Mentoring Network program. For the system thinking module, I'm planning to implement an adaptation next week to a course I teach called Innovation and Entrepreneurship. This is an elective course open to students from different backgrounds, including engineering, biological sciences, business, and social sciences. There are around 60 students enrolled, and they come from diverse careers and age groups. Since most of them are not from the natural science, I adapted the module by connecting it to the United Nations Sustainable Development Goals. Each team will choose one of the SDG that resonates with them, such as climate action, zero hunger, or affordable and clean energy. And we will use system thinking tools to map out the challenges, actors, and interconnections related to that goal. We'll work with simplified tools to identify feedback loops and intended consequences and areas of intervention. Although I haven't implemented it yet, I'm excited to see how students respond. And looking ahead, and most important, I will include system thinking in another course I teach in the second semester called Green Chemistry and Green Engineering, which I launched last year. I believe it will enrich the students' understanding of sustainability and deepen their engagement with green design principles. Also, I just want to say how meaningful it has been to be part of this FMN group. It was amazing. What the ACS is doing with this program is incredibly important, especially for those of us who are physically far away but share the same goals and values. Your leadership, generosity, and trust in us has created a strong sense of connection and inspiration in all of the group. It's been a wonderful experience, and I'm truly grateful to be part of this global community. Finally, and most meaningfully, I want to offer my heartfelt thanks to David and Sarah for their constant guidance and encouragement throughout this journey, a hard journey, but beautiful. Their thoughtful leadership and genuine support have truly shaped the way I approach teaching, especially in bringing system thinking and sustainability into my work in green chemistry.
Hi, my name is Cynthia Woodbridge. I'm a chemistry professor at Georgia Gwinnett College. I've also been a part of this community for this past time. I worked on the systems thinking module as well, and I used really only units 1 and 2 in the module. I implemented this in my inorganic chemistry course this past spring. This is 14 junior and senior chemistry majors. What we did was in Unit 1, we worked on the vocabulary piece. Students mostly did that on their own. And for our first lab, as part of Unit 2, we did the exercise on the Sustainable Development Goals. Okay, those were the pieces that we used. We did have a quiz on systems thinking, and the students did well. I did have a question on the final, but doggone it, they didn't take the final because they aced the ACS exam. So, but that's okay. That's okay. I am working on assessing their results and seeing how I can implement this in future courses. My summer school starts in May, so we'll see how that goes. And one thing I would say is the systems thinking module sort of has a reputation of being scary. It's not. Take it in small chunks. Do what you can and take it in small chunks. It's really cool work. Okay. I would echo everything Flavia said about the quality of this community and working with not only David and Sarah, but everyone else in this community. It's been really great. One of the things I appreciate a lot is the accountability. Having to do something by a certain date really helps it get done and not just fall to the bottom of my list. But it's been wonderful. Thank you to the ACS for sponsoring this, and this has been a great thing.
Hi there. My name is Julian Silverman. I am a chemistry professor at the Fashion Institute of Technology. So none of my students are science majors. I looked at adapting the stereochemistry module, which is a standard, organic chemistry topic. In teaching a chemistry for cosmetics course, the goal was to teach them this, vitally important topic. So I kept a lot of the learning objectives, but a lot of the context and examples were changed. These were for small groups of about 20 students, and we created just really an ungraded activity where they begin to explore different molecules and whether or not stereochemistry can impact their functions in bodies. So really applied. The goal was to, kind of bring up the level of the content that they were addressing. So I'd argue this was one of the hardest things they did in the class. And there were some graded questions on an exam, which they didn't do great on, but that was perhaps to be expected. My first time teaching and also their first time addressing this topic. One of the best parts of the FMN was being able to, of course, create the content and get some feedback, but also realize that it's an ongoing process, that this is really just the beginning. So again, there was both ungraded and graded work. Overall, the pilot did go well, even though the students knew that it was a challenging topic. They dug in, they saw the value of the content. And of course, the connections to systems thinking, which is something we address a little less by name in our course, but still in concept. So yeah, interested in the future in kind of, coding it into the syllabus a little bit more. So we can, of course, assess some of their work as well. And with regards to the network as a whole, it was great as someone who works with very few other chemists on campus, getting their understanding of, the level of content maybe in some of their science courses as it relates to my non-majors courses, but also, of course, just connecting and sharing some ideas. Some of the work that we're doing will be presented this summer at a conference hosted in part by the ACS. And I'll work with a lot of my colleagues here on this call, but also be able to bounce off ideas with them there. So the most important part is this is, again, just the beginning. And I look forward to continuing this work, but of course, working with everyone in the future.
How's it going? My name is Justin Orlando, and I am a chemistry professor at St. Louis Community College Wildwood in St. Louis, Missouri. And I worked on the ideal gas law module. And so I brought this to my Gen Chem 1 class, which actually sadly only has about 10 students in it, but conveniently, that's a great number to work with when we're trying to introduce something new. And I think the right out the gate, the biggest challenge I had is because I'm teaching high school and college students, how do I basically get them all the content they need for especially the high school students, but also kind of introduce this idea that it's more than just doing rote stoichiometry and all of our basic chem stuff. And so what I ended up doing was I ended up using some of the lecture material from lecture 1.2 from the module on SOCMEs and introducing systems thinking in the context of how what you do in gas systems can affect the larger environment. And really, for me, the biggest struggle was finding the story that I had to create so it could all kind of make sense and weave into the general content. And oddly enough, the thing that I immediately connected to was the spaghetti SOCME that I found, because most people know how to make, or at least some sort of noodle dish, and most of my students thankfully did. So I modified my lecture to basically use, since gases were the last stoichiometric thing I was going to talk about, the module was going to be my love letter and farewell to stoichiometry, and showing students that what you do in the small space and lab has a major non-trivial impact on everything, from everything you buy and use in the lab to the byproducts you make from all your stoichiometric calculations. And the students seem to really latch onto that idea, and using the spaghetti as kind of the intro sock me to get this idea of how to connect different systems together. They had really no problem at all talking about the PV equals nRT equation in terms of a SOCME, and then expanding that into the idea of the Haber-Bosch process as being something that has all these interconnecting parts to go out into the environment. And they really seem to like it, which I wasn't sure with this class would be the case, but they really dug deep and they were really excited about the idea that, oh, wow, this affects that in a way I never thought about before. So I think the modules are definitely doing their work in that regard. As far as future work, I really would like to introduce the idea of systems thinking and SOCMEs earlier on in my course into different units and kind of introduce the idea and make it more organic throughout what I'm doing. As far as this committee, I absolutely I look forward every Friday to being on the FMN and seeing everybody here. It's been an absolute blast. The accountability, but also just the support. I'm the only chemist on site, so having like-minded chemists that I can speak to about these things, trials, tribulations, successes, failures, it's been lovely. And you all are amazing people, and thank you for your time. So awesome time.
Hi, everyone. My name is Yibin Wang. I'm currently a chemistry professor at Harrisburg University of Science and Technology in central Pennsylvania. For my implementation, I integrated the ACS GCI hydrocarbons, fuels, and feedstocks module into my one-semester Chemical Principles for Engineering course. There were only 7 engineering students this term, which fortunately made introducing green chemistry content a little bit more feasible for me. I embedded the slides from units B, C, and D of the hydrocarbons module into the organic chemistry portion of the course, and also added an energy infographic assignment to activity B2. Overall, the implementation went smoothly. To my delight, the engineering students quickly sort of grasped the systems thinking as its relevance to their field was quite obvious to them. And they also really appreciated real world topics like the octane rating of fuels that they see every day, but didn't really have any understanding of it. The sustainability of feedstocks discussion also dovetailed really nicely with the green engineering section of their textbooks. For my next steps, I plan to investigate some additional alternative assessment strategies, such as peer review, concept maps, and case studies to further deepen students' understanding of systems thinking and sustainability learning, and also to adapt this approach in both my general chemistry and biochemistry courses as well. Lastly, I want to convey my sincere gratitude to Sarah, David, and my colleagues in this ACS GCI implementation, FMN, for their support and insight over the past year. It's been an amazing experience. So thank you, ACS, for sponsoring this FMN. My top 2 takeaways are: 1, we're all part of a wonderful community of educators, so please don't hesitate to reach out if you need some assistance. And 2, to really adhere to the wisdom of the proverb that sort of, states, the journey of 1,000 miles begins with a single step. If you're like me, the idea of incorporating an entire module into your course may seem overwhelming at first. So start small. Identify the module you're interested in, select the components that fit your teaching style or course content, adapt them, and then share your reflection on what worked, and perhaps more importantly, what didn't work, so the community can learn from you and we can all benefit and grow. Thank you.
Great. Well, thank you, Sarah, and all of the instructors on this call and the couple who are not here today, for all you've done to ensure the success of this FMN, which actually has been up and running more or less bi-weekly since September of 2024. I'm David LaVisca, Portfolio Manager for Green Chemistry and Sustainability in Education at the ACS GCI. And this initiative is one of many mechanisms we are employing to help support faculty as they reimagine the ways they teach chemistry in higher education. This FMN is the first of what we hope will be many future ones that bring together chemistry instructors to brainstorm, adapt, and customize curricular resources, and share best practices and effective pedagogy in the chemistry classroom, laboratory, and across the sciences, actually more broadly, as you heard from some of the folks today. Many of the instructors you've heard from will become mentors in future iterations of our FMNs, and we hope that you will join us starting in fall 2025 or as part of another future cohort. Please feel encouraged to dig into our curriculum materials and join the conversation. We want you to add your voice, perspective, and experience to the conversation, and we hope to collaborate with you soon.